Good morning all. Today we will be starting the new topic, that is method of sections. Earlier we have done the method of joints to calculate the unknown forces in the members of a truss using method of joint. In that equilibrium of joints we have maintained. Now we have to do the second method, that is method of section. And we, by the time you can understand that in case of method of section, what you do, you cut a section. So what is this method based on? So this method is suitable when forces are required only in few members. Okay, so when you are talking about any truss and you require the forces in few members, then suppose there is a large truss and you have been asked to calculate the force in the member AD and EF and CG. For example, you are taking only three forces you have to calculate. In that such cases, you have to calculate the member forces using the method of section. In this method, whole truss is cut into two portions and equilibrium of each portion is considered. Okay, so what you will do, you will cut a section such that it will divide the truss into two parts. Okay, either you will consider the left part of this truss or you will consider the right part of the truss. So for two portions of the truss, following equations of equilibrium should be satisfied. So now what you will do, you will satisfy the equilibrium equation, and you know that the equilibrium equations are summation fx equal to 0, summation fy equal to 0, and moment about z is 0. So these are the equilibrium equation you have to follow in that case. So to determine the unknown member forces, an imaginary section is cut in such a way that unknown force can be determined using above equation. So what you will do, I have told you, suppose you are having any truss, so you have to cut the section. So section here it is defined by an imaginary section. Suppose this dotted line here in this diagram, you can see if this is a truss and I want to calculate the forces in member HG, for example. So I have cut a section such that it divides the truss into two parts. So in that case, I can easily calculate the force in member HG. Okay. So basically, this method comprises of the equilibrium of a section of a truss. So the advantage of the method of section is that the force in any intermediate members can be found directly without finding the forces in any other member. So this is an advantage of this method. Advantage, suppose in method of joints you were considering the each joint for calculating the member forces. Now here if you have been asked to calculate the forces in certain members, then in that case you will apply the method of section by cutting the member using a section imaginary line. Okay, so in that case the advantage of this method is that you can find the specific forces in the members, and intermediate member forces can easily be found directly. Okay, without finding the other member forces. So what is the procedure behind it? Procedure says that first of all you have to find the support reaction considering the equilibrium of entire truss. So first of all you will consider the whole truss, and in that case when you are consider the whole truss, after that you will calculate the reactions by that you know that how you calculate the reaction, that is based on the equilibrium equation, that summation fx equal to 0. This is for equilibrium of all truss. Summation fy equal to 0 and moment about any points equal to 0. So these three equilibrium equation you will apply and calculate the unknown reactions. Now you have to cut the member. For second point says that cut the member under consideration by a section 1 1. So if you will start cutting the section, so name the section as 1 1. It depends upon you what section you name it. So I am taking 1 1 section. Suppose I have cut line such this, so this is 1 1. So this is an section I have cut, and consider the equilibrium of either left hand side of 1 1. So you have to consider either left hand side of 1 1 or right hand side of 1 1. So this depends upon you, and then you have to use the equation of summation fx equal to 0, summation fy equal to 0, moment about z equal to 0 to find the unknown force. Okay, so this is the procedure in method of section. So write down a note that says that cut the members such that entire truss is divided into two separate parts. So the cutting of the section depends that you have to cut the section such that it divides the truss into two parts. So either left hand side equilibrium can be maintained or right hand side equilibrium can be maintained. In case of note 2 says that preferably don't cut more than 3 members. Okay, so when you are doing method of section, you don't cut more than 3 members until and unless there is a condition. For that I will going to tell you about that. The method of sections, we have only 3 equation of equilibrium. Okay, in case of method of sections, you have 3 equilibrium equation, that is summation fx equal to 0, summation fy equal to 0, and moment about set point equal to 0. So these 3 equilibrium equations are there. So you can only find 3 unknown forces. We have only 3 equation of equilibrium. With 3 equation we only find 3 unknown forces. Okay, so you have to cut the section such that it does not cut 4 members, it only cuts 3 members. And what is the condition for cutting the other members, that will I tell you. Note 3 says that cut the member such that all the cut members don't meet at one joint. So this is a condition. When you are doing method of section, you don't cut the more than 3 members, preferably. Okay, preferably you don't cut 3 members, more than 3 members, and you have to cut the members such that it don't meet at a single joint. Okay, so if they meet at a one joint, so third equation, that is summation moment about this point is 0, becomes useless. So this equation become useless equation and it becomes a method of joint problem. Okay, so this is the case of method of section. So these are the 3 notes that you need to keep in mind, that you have to cut the section such that you have to divide the truss into 2 parts, and don't cut more than 3 members, and, and you have to cut the members such that it don't that those members that don't meet at a single. So this is the concept behind method of section. So here are the certain points that I have made for you, that you need to keep in mind, that the method of section involves analytical cutting the truss into section and solving for static equilibrium for each section. So the first sections are obtained by cutting through some of the members of the truss to expose the force inside the member. So when you will cut the section, then you have to name the forces that are on those members. In the method of joints, we are dealing with static equilibrium at a joint. So in the method of joint, we were dealing with the static equilibrium of a joint. This limit the static equilibrium equation to just the two forces equation. In method of joint, we were only applying two equilibrium equations, that was summation fx equal to 0, summation fy equal to 0. Now in case of a section, when we are talking about a section, it has a finite size. It is having certain size. When you cut the section, it is a left hand part or the right hand part you are talking about. When it is having a finite size, and this means you can also use moment equation to solve the problem. So we are having an additional equation in the method of section that says summation moment about any point should be 0. This allows solving up for 3 unknown forces at a time. So this is the concept behind it. Now the other point says that since the method of section allows solving up to 3 unknown forces at a time, you should choose a section that involves cutting through no more than 3 members at a time. So okay, you have to cut a section that it don't cut more than 3 members. You have to keep this in mind. You can only cut more than 3 members in that case in which the 3 of the members are concurrent, or 2 members are concurrent. Then in that case you can cut more than 3 members. So this is the condition that I want to tell you about. You can only cut the more than 3 members in that case, in which case suppose you are saying that I'm talking about this case. Okay, so these 2 members are concurrent here, so you can cut these 2 members these two are concurrent and third one is non-concurrent here. So you can cut in such cases where two or three members are concurrent. In that case you can cut more than three members and solve the equation or truss, analyze the truss forces. When a member force joint towards the joint, it is attached to the member is in compression. When a member force point towards the joint, when you are talking, this is the concept that we're using earlier also. When the force in the member is towards the joint, that says the member is in compression, and if the force points away from the joint, it says the member is in tension. So this is the concept behind the method of section. Now in this example, let us it is saying that consider a truss shown below. The forces in the member HG, CD and HD are required. HG, CD and HD. So in that case, three forces of intermediate section it is asking. So I have cut a section XX here. So you have to cut the truss along the section XX and consider the equilibrium either of left hand side or right hand. So this is the left hand side which is showing forces FHG, FHD, FCD. Here also this is the right hand side. So you can consider either of the part, either left hand part or the right hand part, and then consider the equilibrium equation. Okay. So this is all about method of section. In next lecture, we will be moving to solve the numericals based on method of section. For now, thank you very much, and go through the, if you are having engineering mechanics books and start solving the numerical that are based on the method of joints and method of sections. The concepts of the both the methods has been told and discussed with you, and method of joints numerical has also been discussed. So now you can solve the numerical, and if you are having any doubt you can ask me. Thank you very much.